Okay, so this is the first set of homework examples that we're going to have for 8-4, and simplifying expressions is what we're going to be doing. Trigonometric expressions using our trigonometric identities. Okay, so all that says is take each one of these expressions. Notice they're expressions because there's no equal sign. So you want to make sure that you don't have equal signs on these. So all you're going to do is substitution in order to break these down into a simple trigonometric identity. So your answer should be some in the form of some kind of identity or simplest possible term. Okay, and I'll show you what I mean by that. So in this case, we take the tangent of theta times the cosine of theta. Now you have to use a trig identity, right? So remember, the tangent is the same as the sine of theta over the cosine of theta, right? And then we're multiplying by the cosine of theta. What happens there is the cosines cancel, and you end up with a simple trig function. So this tangent times the cosine is equal to this, is the same as the sine. So all we're doing is using a trig identity, right? This is the tangent, theta is equal to sine over cosine, right? Once you do that, you substitute, right? So you're substituting this identity for the tangent of theta, and then you're simplifying that, or you're breaking it down to a single trig function. So that's what we're looking for. We're looking for how can we take this thing and break it into a simple trig identity or a simple trig function. And in this case, if you'll notice, this is a difference of squares, right? A minus b times a plus b. That's a difference of squares. So that's going to be a squared minus b squared. So that says if we do FOIL, right, we get 1 squared, the two middle terms cancel, minus the sine squared of x. 1 minus sine squared of x, remember, is the same as, right, is the same as we use the Pythagorean identity, the cosine squared plus a theta of x plus the sine squared of x is equal to 1, right? If we move the sine squared over, right, then this becomes the cosine squared of x, right? Because what we're doing, the sine squared of x is equal to 1 minus the cosine squared of x. Oh, I'm sorry. I have to solve for the cosine in this one. So the cosine squared of x is equal to 1 minus the sine squared of x. And then we substitute the cosine with this. And then now we have a single trig function that we started with in this case. And then this one, the same thing applies, right? From our Pythagorean identities, where we use, I'm going to switch this. The reason I'm doing this is because I see the squares here. I see those squared, so that means that I'm going to switch these out with their equivalent trig identity. So remember, from our Pythagorean identity, we have 1 plus the tangent squared of theta is equal to the secant squared theta, and then the cotangent squared of theta plus 1 is equal to the cosecant squared of theta. So we have those two identities. So what I'm going to do is, since the cosecant, right, the cotangent here, I'm going to solve for x, and this becomes 1 over the cosecant squared theta minus 1 minus the cosecant squared theta x. And then what ends up happening is the cosecant, you take away the cosecant, so this one and this one end up canceling, and then you just get -1. So what we're doing is we're using our trig identities, substituting them into our expressions, and then breaking these down into a simplified version of the same thing. So all we're doing in this case is simplifying expressions, and you know you're done when you break it down to one trig function, usually with no plus or minus signs. Well, in this case, we have a -1, but that's just one simple number. So what we're doing in the first set of homework is simplifying using substitution, using the trig identities as substitutions.